Hello everybody, I hope you're doing well and welcome to the platform of CodeChef. So today we'll be solving the problem J reads safely or not. The difficulty level for this particular problem is simple and the prerequisites required are just basic implementation. So this is your educator Ansh and I hope you like my video. Let's move on to the problem statement. Hello everybody, so first of all it is my humble request to kindly read through the problem statement carefully before jumping on to the solution. Now, let me just summarize the entire problem statement carefully. So basically, in this problem, we have a two-dimensional grid. So let's say I have a graph with my two-dimensional grid. Now, for any particular thing, we have my n comma m as boundaries. So say in this particular question, say my boundary for my x-axis, which is n, so let it be here, and for my y-axis, let this particular coordinate be m, so which is here, right? So now my valid range. So the question has described three types of criteria. Now the question told that they will give x comma y as my particular reaching point. So say my x comma y is lying here, right? Then initially the person is starting at origin, so 0 comma 0, and then a person has to follow a sequence of steps. So consider any steps left, right, up, down. So by moving left, the person will move to the left by 1 unit, and by moving right, the person will move right by 1 unit. Similarly, for up, the person will move up by 1 unit, and for down, the person will move down by 1 unit. So from after moving 1 unit, the position of left will be my minus 1 comma 0. My position for up will be 0 comma 1. Position for right will be 1 comma 0 and position for down will be 0 comma minus 1. So this is moving by 1 unit. Now, so chef has given us a string which contains the entire sequence, and chef is saying that the person will move in this particular sequence. So say like the person first moves left, then let's say this is my string. So the person first moves left, then again he moves left, then he moves right, then he moves up, and then he moves down. So whatever the final position that the person will reach at the end of the string, if that particular position lies outside this box of 0, like outside this block of 0 and n comma m, then my person lies in the danger zone. So all the area here outside the box is nothing but my danger zone. If my person is able to lie in this particular box and then he reaches anywhere except my final point x comma y, see the final position is here. So then so if my print was danger, I had to print danger. If the person reaches anywhere in the box except x comma y, then we have to print that he reached somewhere, and otherwise if he reaches exactly at x comma y, then we have to print reached, right? So these are the three cases as told, like I just suggested us in the question. So this is the question what is asking, and let us go to the test cases to see how the thing, like how the answer for this particular test case has come. So yeah. Okay, so here in this particular test case, we have my n comma m as 20 comma 20. So consider my x coordinate is 20, and here we have a boundary of 20. Similarly, consider my y coordinate is 20, and here we have a boundary of 20. So this is particular box in which the entire game has to be played. All outside this particular box is the danger zone. So now let's just see our particular string. So our target goal is 4 comma 5. So my 4 comma 5 will lie somewhere around here, and this is my target goal. Okay. So now a pattern string is nothing but LLU. So let me just give a shortcut to write the particular string. So what we can do is we can just simply observe what is happening in the x-axis and what is happening in the y-axis independently. So let me just brief you how this works. How this works is consider my two L's. So I know that I have two L's. Then consider how many R's I have. I have my 6 R's. So I have 6 R's. So effectively my X will go to two L's, and that's why it will go left two times, and hence the current value was 0, but then the value will become minus 2. So the final value will be minus 2, and then my finally this X will travel 6 times in the right side. So it will go to plus 6, and as a result my final X position is 4. Similarly for my Y, the initial position is 0, but then it moves up 1, 2, 3, 4, 5 times. So finally, my up will be in the upward direction, which is plus 1, and since it's occurring 5 times, it will be plus 5, so the final position being 5, and hence, in the first particular in the string, the answer is 4 comma 5, and it has reached. So I have exactly reached my particular point, which also lies in the safe zone. So hence I'll print reached for this case. Similarly, in the other question, I have my let's just say I have my 10 cross 10, which are the borders. Okay, so we have my 10 cross 10. Then I have my 3 cross 4 as the reaching point, and then I have my 7 length of string. So as you can see, we go up, up, so basically 2 times up, and we go 3 times down, then we go 2 times r. So basically, initially let my x coordinate be 0, and then we are going 2 times right, that's why it's 2, so which is plus 2, simple. And now I have my y coordinate initially as 0, but it goes 2 times up, so initially plus 2, which is 2, but then it goes 3 times down, so it becomes minus 3, which becomes minus 1. So since I am not lying in the block, like anywhere in the minus 1 is obviously in the negative y axis, and anywhere in the negative y axis is outside the block. And since we are occurring outside the block, then I print danger. So yes, this is the test case. Now let's see how we'll approach such kind of problem. Okay, so now to form the approach of this question, you must have guessed that we can just simply take the count of all of my L's, U's, R's and D's, and then what we can do is we can estimate the final position of the string, of the final position of the person. So initially if I'm starting at 0, comma 0, then I can simply just add the count of, like I can firstly, whatever my count of L's is, so since L's is going left, so I can just subtract L, like consider my x coordinate as 0. So whatever the count of L's is, I can subtract the value of L, and whatever the count of R's is, I can just add the value of R, and then I'll get my final position of X. Similarly, let my initial position of Y be 0, and whatever R's that the particular string has, so let's see, okay, so whatever. So consider the initial position of y as 0, and see whatever downs that we have will be treated as minus d because it will go to minus 1 coordinate and d times, so minus d. And similarly, for whatever up coordinates that we have, it will be treated as plus u, and then I'll have my final coordinate for yf. So I simply have to subtract the L and D coordinate from x and y respectively and add R and U from the x and y respectively in order to get our final position. Now once we get our final position, it is simple. So if my final position is equal to the target, so it is my x target and y target, then I have reached my final destination. So I can easily print reached. So if my final position has not equal to x comma y, then, and if it lies in the safe zone, so my safe zone is nothing but my x should be between 0 and n, and similarly my y also should be between 0 and m. So if this particular case is valid, then I have reached somewhere in my grid, but not on my target. So I'll print somewhere. And otherwise, if none of these cases are satisfying, then obviously I'm lying in the danger zone. So yes, this is the approach for the problem. Now let's move on to the test cases. Okay, now let's try to understand the code for this particular problem, right? So here we have initialized all my required variables in the beginning and took them as per the input format. Now, as we discussed, we just declare our up, down, right, left initially as 0 because the initial position is 0. And then my final x and final y also we initialize temporarily as 0. Then similarly, if I go my up, then I increment my up counter, then down counter. If it goes right, then right counter. If it goes left, then left counter. Similarly, as we discussed in the approach section, my answer is nothing, like my x coordinate effective transfer is nothing but r minus l, and then my y coordinate transfer is up minus down, whatever the count is. So if my particular final position is equal to my x comma y, which is my destination, so I print reached. If that is not the case, and then my final position is inside the borders, like it's not inside the borders, like it is outside the borders, so we print danger. And otherwise, if all of these cases are failing, then we simply print somewhere, And let me just run the cases to show you that everything is working correctly or not. So as you can see, we got the correct answer for the sample test cases. Now let's run it through the actual test cases to see that whether everything is working correctly or not. So as you can see, we got the correct answer for this problem and this is the approach. Now let me also show you the Python implementation. So the Python implementation, we do the same thing, that we just take x comma y, we increment. So here instead of calculating LR, I just directly decremented here itself in the loop. So even that implementation is fine. And finally, the final condition remains same, that if my destination is there, then I print reached. Otherwise, if my it is outside the box that we discussed in the approach section, then we print danger. Otherwise, we print somewhere. So yeah, this is the approach for this particular problem. So I hope you like this video. Please like, share and subscribe to the channel. Thank you.